This is podcast 3.5 for chemistry, and today we're going to move on away from ionic compounds and we're going to talk about naming and writing covalent compounds. So the first one, naming rules for covalent compounds, they look similar. You name the first element and then you name the second element, giving it the "-ide" ending. That is a lot like the ionic compound naming rules. We just need to add in the idea of prefixes though. So with covalent compounds, because there's not set charges on these things, we're going to have to use prefixes to tell how many atoms of each type of element that we're using. So it's really important that you write down those prefixes that are right here in this table and you know what they are. The only one you need to know that can be a little different is mono. The rule with mono is that it's never used on the first element. Sometimes it's never used at all. It just depends on, I guess, the person who's writing it. But for us, we will use mono if it falls on the second element. We'll just never use it on the first element. So write those down. All right, diving into naming practice. What you're going to do is you're just going to name the first element. So P is phosphorus. Phosphorus. And then H is hydrogen. Hydrogen would become hydride, and I need to tell that there are three. So this would be phosphorus trihydride. All right, carbon. It's not monocarbon because carbon is the first element. We don't use mono on the first one. So it's just regular carbon. And then I have one oxygen. So that would be monoxide. When you're using those prefixes and the element you have starts with a vowel, like oxygen is a very common one. So if oxygen is your second element, you usually drop off that last vowel. So if it's mono, you would drop that O and it'd just be monoxide. Or let's see, hepta. If I had 7 oxygens, it would be heptoxide. I wouldn't use that A. So it kind of just takes practice, but a lot of times if it's a vowel that starts your element's name, you're going to drop the prefix's last vowel and then just kind of tack on the element after that. So nitrogen, and there are 2 nitrogens, so I do need to put dinitrogen. I need to say that there is more than one of the nitrogens, and trioxide. All right, this is water, but if we want to do the official name of water, it would be dihydrogen because there are 2 hydrogens at the beginning. And then monoxide, 1 oxygen. And then Xe is xenon. And 6 fluorines. 6 is hexa, so hexafluorine would become fluoride. All right, so let's go the other way. If we want to write the formulas from the names, we don't have to worry about charges. We just put exactly what it tells us in the name. So carbon, there's no prefix, there must be one of them. Di means 2, and oxide is oxygen, so CO2. Diphosphorus, di being 2, phosphorus is P, so P2. Penta is 5, and that's chlorine, so Cl5. Boron, if there's no prefix, there's one of them. Tri is 3, chloride is Cl, so BCl3. Carbon, no prefix, so it's just carbon. Tetra is 4, hydride is hydrogen, so CH4. Dinitrogen, di being 2, pent is 5, oxide, so N2O5. So those should go pretty quickly for you because you don't have to worry about balancing out all your charges. There are a special type of element, I guess you could say, that go along with covalent compounds. They're called diatomic molecules. These elements are never found as individual atoms in nature, and there are 7 of them. So you need to know what they are, but they are also listed on the back of your periodic table in the upper right-hand corner. It tells you what all 7 of them are. So diatomics always exist in pairs. So our example here on the periodic table, so you can see where they are, hydrogen is one of them, and then the other 7 go here, and they actually make a 7. So you have the 6 right there plus hydrogen. So those are your diatomic molecules. If I said hydrogen, just hydrogen, all by itself, pure hydrogen, hydrogen is H2, and you can do that with the rest of those. So how you name them is you just give them the name of the element like I did. If I say it's just oxygen, I really mean O2. Fluorine is F2. Nitrogen is N2. Here is the big mistake people make though. If once we learn about these, they try and put them, I guess, as pairs in everything. So for example, if I had, I don't know, something oxide, they would think because it's oxygen, I have to have 2 of them. This only holds true if they are all by themselves. So please remember, diatomic molecules are only when they are all by themselves. We're talking about just that pure element. And that's it. So you don't have to memorize the diatomic molecules. They're on the back of your periodic table. And then you need to make sure that you do memorize those prefixes, though, that go with naming covalent compounds, because you will not have those for the test.